The broadcast is now starting. All attendees are in listen-only mode.
Hi, I wanted to welcome everybody to today's presentation on Fusion 360 API. And my name is Brian Ekins. I'm the designer for the Fusion API, and also work with ADN and be helped to support the API as more of you start to use it. And we give people just a couple of more minutes to come on. I've got a little poll here we can try. And during the presentation, you'll be able to ask questions off to the side and either save those up for the end, or there's some other people from Autodesk watching and maybe be able to answer some as we go. All right, so there's the results. So I see quite a few are just curious about what Fusion is. So hopefully you can answer some of your questions. So this presentation is focused on the API, but we'll learn a little bit about just Fusion in general too. So let's go ahead and get started. And so here's what I hope you get out of this presentation. And I think it's listed as being scheduled for 2 hours, but that was just what was scheduled. That we're going to be closer to, should be under an hour. And but here's what I hope that you get out of sitting in on this presentation is understand what a script is and what an add-in is, and have a basic understanding of what we call the object model, and know what the API can and can't currently do, and then just what's available with Fusion to help you write and run and debug programs, and then what documentation is available. So, and first I want to clear up a little bit misconception. So there's been an API in Fusion for quite a while, and I can't remember exactly when it came in, but it's an old, we call it legacy API, and in this latest version of Fusion, it's even called legacy. See, Addins legacy, and that is going away. So part of the confusion with that is on the Exchange store now, there are some apps for Fusion, very few of them, but they're using this old legacy API. And now with some of the functionality, we're getting into the API, and especially some that just came in this release that I'll talk about, and what's coming in the next couple of releases. We should start seeing a lot more apps for Fusion start to show up on the Exchange store, and hopefully you'll be able to participate with some of that. Right. But so there's this old API, and I'm not talking about that at all. That'll disappear at some point. But there's this new API. And sorry, I think I've got the wrong. Need to get rid of this poll here. There we go. So here's just a objectives. Hopefully we get out of this, and here's about the old API. Sorry about that. And now about the new API. So it's new. It was released for the first time just this past September. And in that September release, it supported writing scripts in JavaScript. And then in November, we added support for Python. And now this release earlier this month, we added support for Addins. And in the future, we'll support also C++. So those are some kind of bigger milestones with the API. And something that's kind of interesting with the API is, so there's multiple languages. So today, Python and JavaScript, and coming C++. We'll see, nothing else is planned right now, but we'll see in the future. But so there's multiple languages supported, but there's really just a single API. And when I design the API, I actually design it in a language that is language agnostic. It's not specific to C++ or Python or JavaScript. I just design the API by saying, here's an object, and here's methods on it, and what are the arguments for that method. Here's a property. So I just define what the API will look like, and then a process looks at my design and then automatically creates the internal code to support that, and wrappers get built for each language. So there's this, and the API is exposed through what we call an object model, which I'll describe in a little more detail. And you have this object model, and each object in this structure represents an object in Fusion, and some that are API specific. And we'll look at an example in just a second. And something that's confusing to some people that are new to this is an object model is showing ownership between objects. It's not representing any kind of inheritance model. So that's separate. Okay, even though there is some inheritance, but this object model chart that I'll show in just a second is just showing ownership between objects. And there's one special kind of object in this, it's API only, called a collection. And collections provide access to a kind of set of related objects, and they also support the ability to create new objects, and we'll see that in just a second in this example. So here's the entire big API object model, and with this last release it got big enough I had to move it onto a D-size sheet. But so there are quite a few objects, and it will continue to grow a fair amount over the next several releases. But here's a detailed view. I've taken just a section of that object model and blown it up here. So we want to write a program that'll create an extrusion, and I want to show how you would use this object model to do that. And a key object is that top level object called the application object, and that represents all of Fusion. So here's some code that lets me get that application object. So I'm calling, we have a namespace called ADSK, and it's divided up into two pieces, core and Fusion. So core has a lot of just generic functionality, and then Fusion, of course, has the Fusion specific functionality. And then on that, there's the application object, and I'm calling a static function on it to get it. So now in this variable, the app variable, I have a reference to this top level application object. So now we're hooked into this object model. And so next on the application object, I'm calling a property that it supports called active product. And with Fusion, documents are divided up into pieces internally. And so it has a piece where all of the design data is stored. That's when you're modeling with Fusion, sketches, the model, everything is stored in this design clump. If you had CAM data, it's stored in its own clump. drawings would be stored in its own clump. And what this active product is doing is it's getting, in this case, I'm just assuming that a design is open. If something else was open, this would break. But I'm asking the app, give me what the user is currently editing. And so it returns that product, which in this case happens to be a design object. So now I have this design object that you can see in the chart. Right. So then with the design object, I call a property on it called a root component, and that returns a component object. So the root component is the very top level component. If you were in Fusion and looked at the browser, that's the very top one that owns everything else in that document. So now we have the root component, and from the root component, I call sketches property. So now that gives me the sketches object that you see in the chart. And as I said before, so the sketches object is a collection. It's one of these, so it gives me access to all of the existing sketches in a document, and it also supports ways to create new sketches. So that's what this add method is. So on the sketches collection, I'm calling add, and when you create a sketch, it needs a plane. And so that could be a planar face, or in this case, I'm calling this XY construction plane property on the root component. So that's one of the base construction planes, and passing that in. And so that creates a new sketch and then returns that. So now that sketch variable has one of these sketch objects that you can see in the chart. And so next we wanted to draw a circle. And so from the sketch, I call a property on it called sketch curves, and you can see that object in the chart, kind of in the middle under sketch there. So that's another collection, and that collection contains all of the curves in a sketch. So that's kind of everything in a sketch except for text and points. So that and decals or images. So now I've got the sketch curves collection, and then it has a collection under it for circles. So that would give me all of the existing circles. And so now I have a reference to that collection, and then I'm calling the add by center radius on that collection to create a new circle. So I'm creating a coordinate, an XYZ coordinate, by using that point 3D create. And then the second argument is just the radius of the circle. So now we've created a circle. And you can also see under a sketch, there's a profiles collection. So as you work in Fusion, you'll notice this as you draw a sketch, and as areas become closed, they kind of highlight or they fill. And so Fusion automatically, as you draw sketch geometry, is calculating closed areas within that, and those are called profiles. And so this from the sketch is going to the profiles collection, and it's just getting the first profile in that collection. And because I just drew the circle, I'm expecting one to be there, and so I'm just getting the first one. So now I have the profile. And now I want to create an extrusion with that. And so now I'm moving over into this second part of the chart. So from a component, I can access the features collection. And then from it, I can get the extrude features collection. So again, I can access all of the existing extrude features in a document, or I can use that to create new extrude features, and that's what we're doing here. So I have this extrudes variable, which is referencing this extrude features collection, and I call a method on that extrude features collection called create input. And so this is a concept that's used fairly frequently in the API, and mostly for creating slightly more complex objects. And so when I create an input, here I'm passing in the profile and then what kind of operation I want to do. But nothing's happened inside Fusion. So you can think of these, when you create an input, it's kind of like the API equivalent of a dialog. So when you run the extrude command, it's leading you through all of the input that's required to create an extrude. And that's the same thing this input is it's just gathering up all of the stuff that it needs to do to be able to create an extrusion. So I've created this input with some basic information and then continue to provide some more. So in this case, I want to do a distance. I want to just extrude a certain distance. So on that input, I'm doing a set distance extent. This argument false is saying I want to just go to one side rather than symmetric, and then how deep I want it to go. And so I create one of these value input objects. This is something that people stumble over a little bit is when I'm creating an extrusion and defining that depth, that's going to become a parameter in the extrude that gets created. And so a parameter can be defined in the API by just a value that you've calculated somehow, or it could be a string that's an expression. So I could say as a string 1 space in for 1 inch, or if there's a parameter already called length, I could say length divided by 2 or something like that. So you can have strings that have equations in them and reference other things, or just define a simple value with a unit, or I can use a double value like I'm doing here, and then that, since I'm doing length, it's always interpreted to be centimeters. That's the internal database unit for length. And so when I use a real value, it's always centimeters, regardless of what the user is working on. And so the input for this distance is a value input, and here I'm creating it just with a double value, but there's also a create by string where I could do an expression. So anyway, so now we've defined all of the input that's needed for an extrude, and so the final thing is to actually create the extrudes collection, call the add method, and pass in that input object that has all the information that's required, and then the actual extrude is created. So what can you do with the API? And so most of what you can do manually in the UI is, and so most just because the API doesn't have full coverage yet, but eventually you should be able to, anything you do in the UI, you should be able to do through the API. And so some people might say, well, if I can already do it manually in the UI, then why would I want to do it in the API? And we just show a simple example of that, and just run a little script. All right, so here's a script to draw a gear. So it's asking for some input. Click OK. And so here's the finished gear. All right. So could you create this manually? Sure. It's just there's a base sketch that's extruded, and then another sketch that's a single tooth on the gear. That's extruded, and then there's a fillet that does the base fillet, and then it's patterned around. So you could do that manually. You could get out your calculator and figure out the points on that tooth, how to calculate an involute. And so it's possible manually. Would anybody want to do it manually? No. So this is a perfect example of why you would want to automate tasks that you can do manually, but you wouldn't ever want to do manually. So it's things that would be kind of tricky, having to calculate those points along an involute, or in other cases it just would be really tedious to do, and so it's nicer to write a program and just automate the process. Right, so here's a list of what currently the API supports. So as I said, it supports a lot of what you can do manually, and we're working on filling in the pieces that you can't. So in modeling, on the create panel, you can see, so I can do extrusions, revolve, sweep, hole, thread, pattern, mirror. And in some cases, we know of some changes coming in the short term in Fusion, and this is a case for all of these primitive things. So we've intentionally held off on doing the API so we don't have to just change it when Fusion changes. But some of these others are we just haven't gotten to them, and a lot of them are planned for this upcoming release. And so on the modify panel, you can see there's most of it is there, and most of what's missing will be in the next release. Sketch, so most of Sketch is supported through the API. Construction, so those are construction planes, axes, and points. That's pretty much all supported. You can see I have a circle through the assembly panel, so nothing in assemble is supported right now. There's some changes coming in this next release, and so it probably won't be until the following release after that, but that's planned. And there's nothing in inspection or select. The patch environment, there's a little bit today and a lot in this next release, and there's nothing for render, animation, or cam right now. So we have quite a bit for the features. The timeline, like you can see at the bottom here, so that's exposed through the API. So sketches, just what I talked about. Parameters are exposed through the API. You can query and assign materials, and the same with appearances. And there's also some basic A360 access. That is, you can query and look to see what projects you have, what folders are in each project, what files are in each folder. You can open those. You can save files to a particular folder. So that's supported today. Some more things that are more kind of API specific, and is you can, through the API, you can traverse the assembly structure to see what components you have and what subassemblies and what parts are inside those. So that's all possible today through the API. You can also query the geometric information out of a model. So a solid and surfaces are defined by what we call a BREP, or boundary representation. So I can see, I have this model, so say it's a box, so I can look at this and say, it's a solid. It has 6 faces. They're all planes, and they're bounded by lines, and so you can get that kind of information. And also you can get mesh, so like a triangular mesh of representation of a model. User preferences are exposed through the API. Camera related functionality, and you can create commands. We'll talk more about that in a little bit. And with this release just came out earlier this month, we can now do add-ins, which I'll talk about in just a second. So some future functionality, C++ support, and that's not coming in the next release, but hopefully the release after that. And as I mentioned already, assembly joints, the features that are still missing, T-splines is ability to create custom graphics. So none of this is here today, right? Things for sometime in the future, drawing support, CAM support, and much more. And a lot of this, we would really like to hear your input, because there's still quite a bit to do, and we'd rather focus the effort on getting what you want done first, rather than us just guessing. So, all right, so choosing a language. So today, as I mentioned, the API supports both JavaScript and Python, and they both have full access to the API, so there's really not any limitations of one versus the other. It's a personal choice. So JavaScript, you generally think of JavaScript as being used to drive a web page. It's all the intelligence behind the web page, but here it's being used just as a general purpose language. And in fact, you don't have a web page, so you can't display any HTML, at least today. Hopefully that will change in the future. And JavaScript, by design, doesn't have any functionality to access the file system. For security reasons, they don't want you reading, writing files on the user's system from a web page, so there's no file system access. But so we've added some of that to the API just to support JavaScript, because that's something you would very commonly want in a script, to be able to read a file and then do something in Fusion with that data. With JavaScript, you can use any text editor you want. If you have a favorite editor for writing JavaScript, you're free to use that. We do deliver an editor with Fusion called Brackets, and so when you go through Fusion and say edit, the Brackets editor will come up. Hopefully in the future we can make this more flexible, so you could choose some other editor instead. But the editor is used just to write the code, and then debugging is done if you're on Windows in Chrome, if you're on Mac on WebKit browser. So you write in one tool and debug in something else. It runs out of process in its own invisible browser instance. And you can use external JavaScript libraries, so you can import additional functionality through referencing external JavaScript libraries. And Python, so it runs in process to Fusion in its own Python interpreter. So JavaScript, remember, is running out of process. So this runs in process, and the result of that is for two things. One, running in process, and then it has less overhead too, and just how it calls the API. So Python can be quite a bit faster than JavaScript. And some of these numbers, I did some testing, and so just making pure calls, not really testing, not doing anything in Fusion, but just making a very simple call. Python was 275 times faster than JavaScript. And then I wrote another little script that actually did something in Fusion. It drew a whole bunch of lines, and that was 23 times faster. So it's all you can say for sure is it's going to be faster. How much faster depends on what your program actually does. So it might be making a simple call, and then Fusion's taking a lot of time to be able to handle that call. So in that case, you're going to see hardly any difference. So it just depends on what the program does. But so Python has full access to the file system, and you can also use any editor you want to edit, but we deliver an editor with Fusion called Spider. And Spider is also used for debugging. So there's one tool that you use for, or can use for, both editing and debugging. And Python comes with a library to build dialogues, your own GUI development called tkinter. And unfortunately, it doesn't work with Mac. We've had some issues with getting it to work for Mac. It works for Windows, but not Mac. But so neither one of them. And so with JavaScript, you can't use HTML. As Python, you can use tkinter, but it's only on Windows. So neither one of them really have that great of a solution right now for building a GUI. But I'll talk about commands in a second, because it's not a critical issue. And you can also use other Python libraries. There's a rich set of libraries out there for Python to do all kinds of things. So. All right. So here's an example script, very similar to what we looked at before. and it's taking a while for the screen to update. There we go. Okay, so here's an example of a script. Like I say, it's very similar to what we did before, actually a simpler version of that extrude. This doesn't create an extrude, it just draws a circle and then adds a dimension to it to control the diameter of the circle. And so here's the JavaScript, and then I'm going to switch to the exact same program for Python. And it's so slow to update here, but so they're almost identical. I'm going to switch back and forth a couple of times and so you can kind of compare the two. But so here's JavaScript, and here's Python. And so, as I said before, so this really is a good demonstration of how there's a single API. And the only differences between these two programs are just the language syntax differences. So I've got var in front of each variable where I'm using it for the first time in JavaScript, and I have semicolons. And that's basically the only difference between the two. Oh, also JavaScript gets a little pickier about type, so I have to do a cast here to get the design object, and that's really the only difference between the two. So it makes it, when you have really pure Fusion API code, it's pretty easy to port from one language to the other. But then when you start getting into where they're using more language specific functionality, then you have to do makes it a little harder to port because you're converting Python ifs to JavaScript ifs or that kind of stuff. All right, so scripts and add-ins. So scripts is what we've had in the API since it came out in September, and so they're usually, I'm saying here, run and done. It's something you go into the UI, you find your script, you say run, and it might have a dialogue, it might not, but you run it and then it's done, and then to run it again, you go back to the dialogue and say run it again. And add-ins typically automatically get started by Fusion at startup, and then they just remain running through the whole session. And I'll show you how that's an advantage. So it depends on really what you're doing. If you have just some little utility that you use once in a while, a script is a great way to do it. If you have some that you want to do, you want to create a command and have that available all the time, then you would tend to do that as an add-in. And so I'll go into that in a little more detail. So add-ins, there's a little more overhead in building an add-in. It requires a manifest file, just a small little JSON file that has information about the add-in. So what's the name? Does it automatically load at startup? Some other information, description. And in the code itself, Fusion expects that you implement certain functions. So when Fusion starts it up, it calls a particular function. It's called a run function, and so that's kind of the entry point for your for the add-in. And then there's a stop function that Fusion will call when the add-in gets unloaded. But so an add-in is expected to kind of follow some certain rules, and scripts can follow those same rules, but don't have to. All right, so scripts and add-ins, and hopefully the performance here is good enough. I can do a little bit of a demonstration. So I think this slide talks about some things that this dialog does, but I'm going to instead just demonstrate it. So go back to Fusion. And there's this scripts and add-ins command. And so it's divided into two tabs. I have a scripts tab and add-ins tab. And each one has a list of samples too. So these are good ones to go look at. So in my scripts are ones that I've created. And if I expand this, I can see some more detailed information about each one. And for example, here the description. Here's actually where the script lives on disk. And so let's create a new script. So I want to, so I can do that through here. So create. And then here I can now say, am I creating a new script or a new add-in? And is it Python or JavaScript? So let's do a Python one first, and I'll show how that works. And so just give it a name. I could give it a description, an author. That's all optional. And create. So it's created it. So now in here, I can say edit. And so for Python, it's going to use the Spider development environment. And so it's created a skeleton Python program for me. And you can see here it has a main function. So Fusion's just going to run this program. And here's a call to main. And so this ends up getting called and executed. And right now it's just getting the application like we saw in that sample before. And from the application it gets an object called user interface, and that supports access to all of the user interface in Fusion, plus some basic UI tools, like in this case to display a message box. So if I ran this right now, it would just display a message box. But let me go back to the presentation and grab this script code. And I'll just paste it in here. Okay, so here's our program, and I can go ahead and save that. And now I could go back into Fusion and run this from the scripts and add-ins dialog. But I can also run it from Spider. And let me delete what I've got here. All right, so from Spider, I can click this, which would just run it. But instead, I want to show debugging. So I can set a breakpoint in the program, and then click this debug command. So now it starts running. It's actually broken since I did debug. It's at the import statement. Over here on the right, I have this variable explorer, and that's showing me the values of a variable. So far, there's not much to see yet, but I'll just run. And so now it's hit the breakpoint I set, and now I could step through. And so here I see app is referencing application object, and I continue to step through here. So we just created a sketch. I can use the console window to do some more examination. So I could say sketch, and sketch has a property called name. So sketch.name, so it's sketch2 is what we created. But now it's going to create, get the sketch circles collection, and create a circle and add a constraint to that. And I'll just let it run through. And there we go. So it just created the circles. So that's how I can create a new script and debug it for Python. So let's look at doing the same thing with JavaScript. And let me go back to, I'll just get the code from our sample. Just copy that. And we'll go to the scripts and add-ins command inside Fusion. And I want to create a new script just like we did before. Except this time I want it to be JavaScript. So create, and now I want to edit. And so for JavaScript, Fusion by default displays, uses this brackets editor. And so it's again built me a skeleton script. And this top section, the if addis.debug equals true, is used for debugging. So if you're debugging, it will break there. So then you have an opportunity to set other breakpoints. But we want to paste in that code. All right, so now we have our JavaScript code, and I need to save this. So I can't debug from here. This is strictly an editor. So like say you could use any editor you want. So, but I saved this. I can either close it or just leave it open. Doesn't matter. And now to debug, I have to go back to the scripts and add-ins command. And pick the sample, and then instead of run from here, I'll click debug. And so on a Windows machine, which I have, Chrome launches. If on a Mac machine, then the Web Toolkit will launch. And so here's my code running, and it's broken at that debugger statement. I could add additional breakpoints if I want, or just step through my code. I'll go ahead and step through here. So it's just running through. One of the nice things that at least Chrome has, I haven't used a Web Toolkit, but I can hover over a variable and it shows me all of the properties on that. So a product has all of these, so I can click this active component. I can expand it even. And so let's see, sketches, I can expand that. Right now there's 0 sketches in this file. But so that's nice to be able to quickly see the value of some basic properties. So that's how debugging works here. Let me go ahead and just run that. So once it was done, it terminated. So this isn't an error or anything. It's done. And there's what it just built. So I had mentioned earlier that neither Python or JavaScript has a good solution for dialogues, and that it's not, in most cases, probably not that critical that it doesn't, because Fusion has kind of built-in dialogues through commands. And so commands, first of all, they can be used by scripts or add-ins. There's nothing specific about them that they would be limited to one or the other. And Fusion has a very well-defined concept of what a command is. And what that is so you create what's called a command definition. And this command definition has all the information it needs to be able to basically create something in the user interface for that. And I have down in the bottom right a little command. It's supposed to be a paper airplane, but when I scaled it so small, it doesn't show up very well. But so I created this command definition. I gave it the icon. I gave it the tooltip. I gave it a name. I also told it that in the UI you would be represented as a button. I could have checkboxes or a list of items to select from. So there's kind of different flavors of commands. But so I create this command definition, and then I use the API to actually create a control that references that definition. So I insert it into the user interface. And that example below, I've inserted it into what's called the navigation toolbar. That's where all the camera and view related functionality is at the bottom of the screen. So, because this is a camera related command. And so I can insert my command anywhere in the UI that I want. And then when the user clicks that button, Fusion creates a command object. So inside the API, there's a command, there's a class called the command, and Fusion creates one for this particular command and gives it to you. So when you create a command, you connect to an event, and so you're notified when your button gets clicked, and Fusion creates this command and gives it to you. So far the user hasn't really seen anything. He's clicked on a button and nothing's happened, but you have this command, and then on that command object you can create command inputs. And in this case to the right, this example, there's 4 command inputs. The first 2 are a selection input, and the third one is a slider, and then the fourth one's a button. And so there's several different kinds of command inputs, and we're expanding that with each release, what's supported. But so you create these inputs, and then once you're finished doing the inputs, then Fusion automatically builds up this dialog and displays it to the user. And then you connect up to some other events associated with the command, and those events allow you to, as a user is interacting with the dialog, you get input every time they change some value. You get an event to let you validate if everything that's required has been provided, and so that would determine if the OK button is enabled or not. You get an event so you could actually show a preview of the result if you want. And then once it's all done and the user clicks OK, then you create whatever that command is supposed to create, and Fusion automatically knows that all of that API as part of this command get grouped together into one undo operation, and it's all automatic. You don't need to do anything special for that. So it makes it fairly easy to build and interact with what can be a fairly complex command. And so documentation, and so let me demonstrate this. So documentation is available inside Fusion. So you just go to the regular Fusion help. There's not a separate link for the API or anything. And inside the Fusion help, there is a table of contents at the bottom. There's a programming interface topic. And if I expand that, then you can see here, so there's a welcome to the API, what's new in this release, and then these three topics, a user's manual, expand that. So this has some overview information. And so this would be the place to kind of go and get started. So you're writing your first script, how do you create and debug that? So it leads you through what I just demonstrated. Some basic concepts of the API, so that object model and what are collections and inputs, so some things we've talked about here already. What are add-ins and how do you create and work with add-ins? So these give an overview of these topics. And then this reference manual, that lists every object that is in that object model. So here are all of the objects listed. If I expand on one of those, then it shows me all of the methods and properties that has. It's in clicking will take me to the topic for that object, or here it takes me to information for this create by 3 points method. And I see kind of a sample of that in both Python and JavaScript with the tab at the top. And then, so that's the reference manual, and then there are also samples here, and they're linked to from the other topics. So if there was a sample for this create by 3 points, there would be a link to the sample from there. But and then here are just the same samples categorized. And so there's JavaScript and Python code for each one that you can just copy and paste into a program and run it to see that functionality work. All right, so that's the documentation. There's also a Fusion API specific forum. And so there's, you're welcome to post questions there, and there's been some sample scripts posted there from other people outside of the Fusion development group. And so this is reasonably active, and and we watch this very closely, so that if you have questions and or just suggestions, this would be a good place to go. All right, so getting started, the first thing you want to do is install Fusion, and then start to play with it. Get a feel for, not with the API yet, just with Fusion itself, get a feel for what it does, how it works, and then start looking at the API documentation that just described. Probably that user's manual section, just an overview of getting started. And then start looking at the sample programs. So there's the samples that are part of help, and then also quickly showed that there were some samples that you can get to from the scripts and add-ins dialog. And then there's the forum if you have any questions. And said we'd be happy to get input. We welcome input on what functionality that you need that's not there yet, and so we can help prioritize. And so that's what I have for today. So are there any questions?
Brian?
Yep.
Yeah, so there were actually quite a few questions during the presentation. I'm not sure if you just want to scroll through them in the questions area on the panel, or should I just point out the questions that I couldn't answer? So there was, for example, one question is about Cloud API. I seem to remember we were thinking about providing sort of server-side API, right?
There's no plans right now. At some point maybe, but right now there is no server version of Fusion, so it's kind of pointless. But
Okay. Oh. Then there was a question: what version of Python will work with Fusion API?
it is Python. It's the latest. What is it? 3 point whatever it is.
Okay. I'm just going through them. Why do you need a 3D point while editing an XY plane?
Oh, yeah, that's a good question. So sketches in Fusion are 3D. Mm-hmm. So you're drawing in 3D space. So I could have had a value for Z and it would draw it off of the XY plane. It kind of treats the XY plane as special, and so like a circle in that case would be drawn parallel to the XY plane, and so usually you do draw just in the XY plane, but that's not a requirement, and a sketch is a 3D thing.
Yeah, it was also pointed out that loads of things compile to JavaScript. So, for example, someone is playing with Scala, as an example. So I guess that meant that you could develop an add-in maybe in another language as well, and then that would be translated to JavaScript.
I haven't played with that, but I mean, if you can end up with JavaScript code, it doesn't care where it came from. Right?
Yeah, exactly. And then why are the internal units centimeter, just like in Inventor?
That's what the Fusion team chose to use. So.
What was that based on? I seem to remember it was mentioned once that that covers the best, with the best precision, very small and very big objects.
Yeah, it's kind of a medium
like that, right?
range. Yeah. So, probably doesn't cover designing, things for something that would cover a whole city, or maybe stuff at a micron level, or it's super tiny. But for most things, it gives good accuracy. So yeah, it was just a choice they made.
Then another one: are there plans for API support for the HSM component, so the CAM part?
There are plans for that, and we've started doing some initial investigation, but I don't have any dates right now. But there will be an API for that at some point.
And some people would prefer to see the documentation in a JSON format.
The documentation in a JSON format?
Yeah. Well, that's what I understood, right? It basically says, any plans to release a machine-readable version of the documentation on the website? Right now, I'm scraping it to get type definitions. It would be nice to get that in an easier-to-pass form.
I don't know. That's the first time that's ever come up. So, but it could be done easily. The documentation internally is actually stored as XML, and then it's gone through a process to output it into what we see on the web. So it could be done if there's a need and a big enough need for it. Wouldn't be much.
Next one: are we thinking about adding an add function on the bodies collection? So
yeah, so there's two pieces to that. Well, yeah, we are. In fact, I just spec'd that earlier this week. So we should see that either in the next release or the release after, I think. But the one qualification with that is in this initial version, so it would let you create a body from some existing body. So you'd still have to have a body. The part that isn't spec'd yet is being able to create a body from scratch, like you could in Inventor. So that's something we still plan to do too, but that will be a little further out.
So it sort of ties into the other question. Is copy-paste of bodies supported in the API?
No, not yet.
So would that be through the add on the bodies collection? Or?
Yeah, probably that would let you do
Okay.
that.
Can we choose our text editor that would be launched from Fusion? So
yeah, not today. It will always use Spider for Python and brackets for JavaScript, but that's something that we've talked about and want to change. It just hasn't happened yet. So that you could set a preference and say I want to use my other editor for JavaScript as my default. So.
Next one. How do you rerun a script like the Python thing? So do you have to go through the menu and the dialog at the moment, right?
Yeah, today you have to do that. That's where add-ins are kind of nice, as you can create a UI for it. And hopefully Fusion will add some support like Inventor had, where you could easily create a button to run a script. But today you have to go through the dialog every time, so it's kind of a nuisance.
So it says it seems that both scripts and add-ins need to reside locally on the user machine. In keeping with the concept of cloud, are there any plans to allow you to store them on the server so that I could access them from any machine I want to use Fusion from?
Yeah, that's a good point, and that is something we're working on right now. Is so that when you could write a script and it is local, but then it would automatically get synced to the cloud. So when you go work on another machine, that would get pulled down to that machine, and you would have access to it. So
and that was the question.
Oh,
sorry.
Go ahead. I was just going to say, so that is in the plans, just not there right now.
And that was a question, but suddenly I had an idea. But anyway, so how do you jump into the JavaScript debugger from a command? So would you have to add that debugger keyword in the code or something? Would that do it?
Yeah, well, yeah, so you would always want that in the code. And so debugging, I guess by a command, you mean an add-in that would have a command?
Yeah, I guess so.
Yeah, so you would just, let's see. So in that case, so with add-ins, it's optional whether they start at startup or not. So when you're debugging, you would set it so it doesn't automatically start when Inventor starts. Right? So it's just a program sitting out there that's not running, and then you would go to the scripts and add-ins dialog and say, you would click your add-in and say, I want to debug this, and then it would jump in just like we saw. I would start debugging that add-in, and so it would go through the code where it's creating its commands and adding them to the UI, and then it's just going to sit there, and then when I click the button, it's going to hit that event, and I can have breakpoints and all of that and debug it. And so there is one thing I didn't mention earlier is today debugging with Python, there's a couple of issues, and they're corrected in the next release, and those issues are documented in both the add-ins topic in the help, and also there's a topic, there's two topics, and one that's specific to JavaScript and one that's specific to Python, just kind of talking about issues with each one. And anyway, so it's documented there. But a lot of debugging Python, those issues, like I say, are all cleaned up in the next release, but there's workarounds in the current release.
Yeah, and there's a comment which must be based on something you said, but I'm not sure how it ties into your presentation or where exactly it was said. So the comment is, that's actually not quite true. The initial fetch is really just an HTML page, and you can have the JavaScript served from anywhere. in fact, in the latest version, you probably want to serve it from an actual web server, not use a file URL, because there's an issue with reloading the changed file.
Right. Yeah. Fusion doesn't care where it came from. I mean,
Yeah.
but if you have, well, yeah, it's up to you, I guess, where you store it.
Okay. And then with respect to take inter, I'm not sure. I haven't heard of that one. You know what that is?
Yeah.
Did you talk about it?
Yeah, I mentioned it.
So not working on Mac, is that just for development? Could you create a dialog in Windows using that, or and they would work in both operating systems?
No, it's at runtime when there's problems, so it just doesn't work on the Mac. And
Okay.
they've spent quite a bit of time looking at it and haven't figured out a solution. So we've looked at some other potential things. In Python also supports some toolkits to let you use Qt, which is also a popular multi-platform GUI builder, but there's some issues with Qt too. So we haven't found a solution that we can really comfortably recommend that works everywhere, unfortunately.
Okay, any way to talk over network? It would be nice to do some calculations outside Fusion, HTTP fetches, for example.
Well, whatever you can do in either JavaScript or Python, I mean, you can do. So there's nothing in the Fusion API to support it, but whatever those languages let you do, you're open to do.
Yeah, so are there any plans for .NET API?
Not right now. So I think waiting to see a little bit what ends up happening with .NET on Mac now that Fusion has, or now that Microsoft has opened up .NET. So we'll see.
And then tying back to the 3D point object. So when would you use the point 2D object?
That point 2D is used to return things when you're examining a face in parametric space. Then the parametric space of a surface is 2D, and so points in that case would be returned as 2D. But just general modeling is always going to be 3D. So 2D is a very kind of limited special case.
Then another question, so no plans or, I guess, so no plans on the API to support CAM objects?
Well, there are plans, and the initial investigation is we're working with the CAM team now and figuring out how to do it, but there's no schedule right now. But I would expect the beginnings to be this year sometime.
Yeah, and someone says, can you talk a bit about quality? My experience has been that scripts crash constantly. Yeah,
well, I've experienced a little bit of that too, but so I mean the best thing is if you're finding something that's crashing, if you could send it to us so we can reproduce it and fix it, whether it's in the API side or in the Fusion side.
And necessary to add a method to insert a transient object NURBS curve as a fixed curve in a sketch. This will solve the problem of communication with external applications of modeling NURBS curves.
Yeah, and I just added that into at least into the API design last week, and so that should show up possibly this coming release, but maybe the release after that. So this coming release, the development cycle is almost done. They're supposed to be mostly finished by the end of this week. So, but there's some stabilization period after that. So we'll see how much more can still go in. but that's coming.
And another question on debugging. So can you break into the debugger when the add-in is running? So I guess the only way is just putting the debugger.
I think you have to start it in debug mode.
Mm-hmm.
I don't know why I can't.
When using matrix 3, it should be on the panel. Okay,
Yeah,
you go on the panel and
like one line high, and I can't.
Yeah, it's
roll. Oh, there it goes.
Yeah, it's definite. You can see it now?
Well, no, I can't. I can only see one line at a time, and it won't let me expand.
Okay. Yeah, but when you click on it, then there should be a smaller panel underneath it.
Oh, there we go. I moved it off into its own window, so now I can see. Okay.
You can see it now?
Yeah.
So we are on the last two questions when using matrix 3D.
Uh-huh.
So that's where you might have to say it loud, because I don't think the attendees can see it unless you
I'm
actually
just reading
answer.
it for the first time here. So when using matrix 3D for arbitrary transformation, when creating a component, the resulting bodies of the component are broken. When you inspect, the size is always 0. Does it mean that matrix 3D should only be used for translations and rotations, but not for scaling, skewing? Yeah, I haven't really. I've only used it for translations and rotations, but so Fusion itself doesn't really support scaling and skewing, and so I think in the API we probably need to block that. Actually, we're probably passing it through, and Fusion just isn't checking it. It's always assuming that it won't have scaling or skewing, and so it's taking it and doing what it can, but it's not really set up to handle that. So it should just be translations and rotations. So scaling is actually done through a feature. There's a scale feature that lets you modify a body. So you can't just take an occurrence and create a new occurrence that's at a scale. So we need to limit that, make it more obvious, the behavior. And so the next one will be scripts in A360.
Yeah.
Oh yeah, we kind of talked about that. So yeah, so in the future, and this is being designed right now, is scripts will be pushed up to A360 and be managed there, so that when you move to another machine, your script, you'll automatically have access to it. And looks like that's it, huh? For
Yeah, so any other questions from anyone?
All right. Well, thank you everyone for attending, and I say the forum is a great place to learn from what other people are posting, but also to post your own questions. So if you think of some more later. And what do you think about Easy Fusion on GitHub? So for those that haven't seen it, it's kind of a wrapper over the Fusion API to try and make it easier to use. And I think in concept, I like it. I think it's probably just a little too early when the API is still coming. So and a lot of things. I mean, if there's some things that are really hard to use, it would be better to make the Fusion API easier to use itself rather than creating another wrapper over the top of it. So, but I think in concept and what it's trying to solve is a good idea. So we'll see.
Yeah, and there's also a question about the recording and the deck. So I guess we can just post it on both of them, on your blog and the ADM blog, right?
Yeah.
Or just post a link or something.
Yeah, and then I'll post a notice pointing probably to the blog on the forum, too, that it's there. So yeah, we'll make this available.
And also there's a question, will you pick up some ideas from Easy Fusion? So I guess if you're going to integrate some of that into the API itself.
Yeah, sure. We can look at what's there, and I mean, and besides just what's Easy Fusion, just any comments people have.
Yeah, so just again, both the presentation material, the PPT, and the video will be posted later on the Addins site and on Mod the Machine, which is Brian's blog. So you can find it there as well. Yeah, so it does seem like we don't have any more questions. Yeah.
One more. So will Action Recorder be available? So I'm assuming that's like what you would have in Excel to be able to record a macro or script and play it back. And this has been kind of in the plan since we first started designing the API, but it's in the future, and we'll see. I really hope so. I hope it happens, but it's kind of we need almost complete coverage in the API before it's feasible to have record. So we need to wait a little bit for that, and so we'll see. And will it be an inventor server approach for Fusion server? And possibly. I mean, Fusion was kind of designed to be able to support that. It doesn't yet, but it was designed to do it at some point. So we'll see. So it's really more of a question on on the Fusion side rather than API specific. So it looks like maybe that's it.
Yeah.
All right. Well, again, thanks for attending, everybody, and good luck playing with Fusion. So, all right, thanks.
Yeah, thanks, Brian.